Hi everyone, welcome to our channel Data Test. As we promised over the previous video, we are happy to launch Databricks 101 series. Let us start today with Databricks Introduction module. What is Databricks? Let us take a simple example. It could be a superstore like Walmart. What does the Walmart do? Walmart brings together groceries, clothes, electronics, pharmacy, and all under one roof. Just like that, our Databricks is modern superstore for all our data needs. Would you like to maybe store and clean your data? Would you like to analyze your data? Do you like to build your data pipelines? Are you willing to build machine learning model? Or do you want to build a chatbot powered by Gen AI? Yes, all these things you can do it using Databricks platform. It is the data intelligence platform that we have powered by Gen AI. It is the unified data analytics platform where all your data engineering, data science, machine learning, and analytics teams can work together. Under the hood, Databricks is powered by Lakehouse. What is this Lakehouse? We will discuss about it in few minutes. And one more very interesting and favorable fact here is that in Databricks, you can develop your applications or maybe data pipelines using Python, SQL, Scala, or the data science language R. That is again very cool fact. Let's get started. And one more important thing that we have to notice is Databricks is being named as leader in both cloud database management as well as in data science. You can clearly observe that it is being recognized as the leader by the Gartner. Cool thing, right? I hope you are excited to learn such a fantastic okay platform. Fine. I was mentioning that Databricks is the platform powered by Lakehouse architecture. What is that Lakehouse architecture? Let us try to understand it. As you see in this diagram, Lakehouse is something that is giving us blend of data warehouse and data lake. Then you may be getting the question of what is data warehouse and what is data lake. Data warehouse is very popular and kind of traditional solution that we have around for our data problems. Here any organization which is dealing with data, right, it will collect the data from their multiple sources, and after collecting the data from multiple sources, that data will be cleansed, formatted, standardized, and it will be structured, and after structuring it, it will be stored into the data warehouse. So from here, our data analytics teams and all, they can pick the data and they can generate dashboards and all, the analytical dashboards. So one very key highlight here is that we are storing the data in structured format. That's nothing but in the form of tables, the rows and the columns. But then we have vast amount of the data. The organizations have vast amount of the data which they cannot fit in the form of rows and columns. So where do you store such kind of the data? May it be your audio files, may it be your video files, may it be the kind of product reviews that are being shared across the maybe e-commerce websites. So where to store all of that? The go-to solution for such kind of data could be what we say data lake. How different the data lake is from the data warehouse? In the data lake, as indicated by this, right, it accepts data in different forms. And that too, here, right, just like how different streams of water flows into the lake, into the data lake, different flows of the data will be flowing in their raw form. So the data is not cleansed, the data is not standardized, the data is not transformed, it's not curated before it's being stored onto the data lake. So what's the other implication of it? It's not organized. Maybe it's not something that is readily available to be used, especially for our analytical needs and all. Okay, it's difficult to just grab upon the data and utilize it. Maybe the data is fine for being used by our data scientists and machine learning engineers. But what if the part of the data that was there on the data lake is needed for our data analytics teams as well? So then you have to carve out data warehouse within your data lake. So that is again, you have to curate the data present in your data lake. So that way, organizations started building data warehouses out of their data lakes again. So combining these two, right? So we have today the lakehouse paradigm, which gives us the power of data warehousing features as well as the power of data lake features. Your data still will be sitting on the data lake, and for the data that is sitting in the data lake, we will be giving the powers of data warehouse. So what could be these powers of data warehouse and all? Simple things can be like ACID properties, okay, time travel versioning, okay, governance. So all that, right, can be done using the lakehouse. And Databricks is powered by lakehouse architecture. So this is one very important aspect. And other things that I just spoke about, Databricks is a unified platform. It is a go-to solution for all of our data teams. And it is cloud-based. Databricks platform is offered over the major clouds like AWS, Azure, and GCP. Great, right? And one more cool thing is Databricks is a platform built by the original creators of Spark, which is one of the very well-known framework for distributed data processing. And they also developed MLflow, which is used for our machine learning model development. And they are also the developers of Delta Lake. So what is this Delta Lake? I had been telling, using this lake house, we will try to bring the powers of data warehouse onto the data lake. That is possible through the underneath technology called Delta Lake. So with all these cool features, right, Databricks is having great promises for us and our data teams. Let us try to explore upon that in our upcoming videos. Stay tuned. Thank you. Hi everyone. In this video, let us look at how can we create Databricks Express account. All that we need to create the Databricks Express account is the Gmail ID. Let us check here. I'm at the URL provided by the Databricks where we have option to create the Express account. I will just click on this. This is where it is prompting us to uh, provide the email. They suggest that use the work mail ID for best experience, and up to $400 of credits they're ready to provide us. So let me just say here, continue with Google. Just a second. And here I choose my account. Fine, this is account name that's being taken. Country, let us switch it to India. Great, let's continue. It is taking few seconds to launch the workspace. Let me pause the recording for a while, then I will be resuming. Okay, after a while, we are getting this UI, which is nothing but Databricks web application, wherein you can see the different menu items and the important feature over here. Start paying attention from top left corner. We have the menu here, and through this you can toggle the navigation when you would like to make more space over here. And then at the very beginning, we have some sort of shortcut options to create certain important Databricks platform related features, such as option to add or uploading the data to the Databricks platform, for creation of the notebook, creation of the query, the dashboards, for collaboration, the Genie space, the jobs, experiment model and app, and many more things like Git folders, SQL warehouse, and serving endpoint. Focus of this Databricks one not one session is about Databricks SQL. So that is our focus is on the data analytics part of it. So with respect to that, the shortcut menu provides us option here to create the SQL warehouse. The other such cool features that you are seeing are related to data science and data engineering and Gen AI related. Fine. So what you see here after that very handy option over there, we have workspace, the recent items related menu, the catalog, workflows, compute, marketplace, and so on. Workspace is the place where you organize your project assets and all. By default, happens like the Genie space is created for us, one dashboard is created for us, and so recents, if we see, it's empty. The catalog, if I just click on, it gives us, in fact, the Unity catalog enabled, options here. That's where we are seeing that we have by default some catalogs like workspace, the system, and so fine. Um, we will look into these things later on. Workflows is something for data engineering and not focus of this course. Let us move on to the SQL part. We can collapse these personas. Okay, if they are distracting you, and our focus is on the SQL. So let us switch our gear onto that. Very main important thing here is when we are about to explore upon the Databricks SQL related things. Uh, as a as here, right, we are talking about the SQL. Uh, uh, you may be recalling the database related things. Okay, in the database world, we will be having the database server, and you'll be connecting to that database server through some sort of a client like maybe MySQL Workbench, or maybe right SQL Server Management Studio and so kind. So to do the Databricks SQLing, right, we need the server part of it, right? And how are we going to set up that?
server over here. We need not do anything. Databricks being the data intelligence platform and being cloud based, they do uh, take care of the infrastructure and all. So that's where you see here we have the option of SQL warehouses, and uh, I just clicked on it and it's taking a while. And you could see that by default over this Express, account, they've already provisioned for us one serverless starter warehouse, and whose size is medium. And as of now, it's not running, right? Let us just click on start the warehouse. This is nothing but your server, okay, data warehouse server. Once it is up and running, you should be able to connect to this SQL warehouse server and execute the queries. Cool, right? Within, uh, I think, less than 60 seconds, we get here the Databricks data warehouse, the serverless one up and running. And now you are free to write Databricks SQL code using the SQL editor, right? Okay. So this is it for this video wherein I covered how do you set up the Databricks Express account. In the next video, I will be walking you through the other features of the SQL persona here, about how do we write the queries and the SQL editor, what is the dashboard, alert and all. I will brief about. Catch you later. Stay tuned. Thank you.
Hi everyone, welcome to our channel Data Test. As part of Databricks 101 series, in my previous videos, I have covered about introduction to Databricks and how to set up Databricks Express Edition account. Today, I will be discussing about Databricks high-level architecture. In case you have not watched our previous videos, you can follow the Databricks 101 playlist. Let's get started. On the screen, you are seeing Databricks very high level architecture. In Databricks high level architecture, you will be observing two planes. One is called control plane, the other one is the data plane. To understand better, let us have quick recap that Databricks is the enterprise data platform. It manages different data analytics related computation for us. So what do I mean by computation? Computation is about performing our data processing. To process our data, we need the servers, and Databricks is a platform built on top of the Apache Spark, which is distributed data processing engine. Spark is set up using cluster of machines, and Databricks does that cluster management and all for us. So it is an enterprise data platform which provides a lot many things out of the box for us, and now we are trying to understand the very high level architecture of it. As users, when we when we are about to utilize the Databricks services, the very first thing that we have to do is we should be creating the Databricks account. Databricks provides its services over the cloud. We have it on Azure, AWS, and GCP. So if at all we are using Azure, let us say, so after logging into our Azure portal, we can search for Databricks, Azure Databricks, and then we can actually set up the workspace and all. Fine. So that's what we are seeing here, the Databricks account. So from that Databricks account, once you create the Azure Databricks service, so it will provide you the option for launching that service. And once you launch it, you will be observing one web page. Fine. I have told you about that in the account setup video as well. In that, you will be observing all these different things. Fine. You get to see the web application wherein you get to organize all your projects and all. Then You can do your compute orchestration and all. That's nothing but about setting up your clusters and all. And you also get to uh, manage your Unity catalog related meta store, and you get to write your queries, the code, and everything. We will see in a while. Please hold on. Just let us try to have a look at and understand the high level architecture and what are the different components that come over there. So we are trying to control the different aspects of our Databricks development using the UI provided by the Databricks. Okay, that's why all these fall under the control plane. It is true that we are trying to process our data from where the data will be coming. The data will be coming most likely from our cloud storage itself. So that's why it's given here your cloud account. So it will be the customer or the client cloud account. It could be Azure or it could be AWS or it could be GCS, right? That is Google. Fine. So over there, the data will be present, and Databricks can work with that data. So that's what here we say the workspace storage bucket, right? So all of the data will be residing in your cloud account, the user's cloud account, customer cloud account, client cloud account, whatever we have to call it as. Fine. Apart from that, the compute machines, the VMs, the required for running the cluster will also be drawn from the user's account. So that's why it's mentioned to be classic compute plane. Why they're telling it to be classic compute plane? Because nowadays Databricks has started providing the serverless service. Instead of users have to maybe right choose the machines and choosing the cluster configuration and starting the cluster on their own, which could be taking time. So that was one of the pain point that the developers are experiencing. Fine, that's when Databricks is trying to overcome it so that we don't have any initial lag over there setting up the clusters and all. Right, so that's why under the Databricks account itself, they are trying to provide us the serverless feature, uh, so that in almost no time, okay, we will be able to execute our okay data processing and all. Right, so that's what you are seeing here under the Databricks account. Databricks itself is going to take care of some okay setup of the clusters and all. That is a serverless compute plane here. If you are not going for serverless, right, so we can provision for clusters, and for the cluster the VMs will be drawn from the cloud account itself. So that way we could say here the billing related to the VMs that we are using for the clusters and the billing related to the storage will be incurred against our own cloud account. Apart from that, Databricks related, right? So billing will be different. So depending on the consumption that we are doing, maybe serverless consumption, maybe the consumption related to the Unity catalog service of the Databricks and all will be billed under the Databricks account of the user. Okay, so this is how the things are going to happen. And we are seeing here one more thing. From Databricks, we can connect to pretty much any kind of the data source that is available. So that's why we see here it can be the cloud, right? Your data may be residing in other cloud also. It could be that your Databricks account is in Azure, but you can access the data present in your AWS account. So pretty much possible. So any cloud. So it is kind of federated system that we have here. And the data can be coming from your own data centers, or it can be coming from your own maybe premise based databases and all, anywhere, right? So Databricks can work with the data present across uh, different, I could say, right, maybe cloud providers, or the cloud providers are maybe across different maybe data platforms, right? So it can be the case. So that way here you understood today. So how do we go about maybe working with the Databricks, right? Uh, so if we look at, this is what I was speaking about in the control plane, the web application is there, right? So the web application. So this is the web application that we are looking at, and through that web application, we will be able to organize our code base and projects. We should also be able to, uh, uh, I could say, right, discover the different maybe the data objects that we will be creating in our projects and all. How do we go about orchestrating the different tasks that we do, and about our SQL, all those things. So it is through this web application that we are getting access to the different offerings of the Databricks. Fine. Databricks is the unified platform, unified analytics platform. So data engineers can work with Databricks. The data analyst can work with Databricks. Data scientist can work with Databricks. So it is providing the unified platform for us under one roof, which is very great thing. In the upcoming video, I will be walking you through the um, different features of this web UI of the Databricks. Thank you. Stay tuned. Hi, welcome to our channel Data Test. In my previous videos, I have discussed about a Databricks introduction, how to set up the Express account, and the high-level architecture of the Databricks. Today, I will be walking you through the Databricks Web UI. Let's get started. I'm here at the Databricks serverless account. You can observe here. Fine, and let us try to explore upon the different options we have one by one. To the very top left corner, we get to maybe right toggle this navigation bar. Okay, if you would like to make for more room and all, you can try that. Let me just keep it turned on. And to the right of the menu, right, we have this Databricks logo, and below that, very shorthand kind of quick go to tool we have, that is a new. Upon clicking on that, you will be seeing they are giving us provision of uploading the data to the platform so that we can work with it. Creation of the notebook, creation of the query, the dashboard, Genie space, the job, DLT pipeline, alert, experiment, and so on. You could also see that we have something called Git folder, SQL warehouse, serving endpoint, and so these are all kind of drawn from all the different persona that we have, because Databricks supports the SQL persona, that is data analyst, data engineering persona. It also supports the machine learning persona. So that's where the quick handy operations we can do in different personas are provided over here. Our focus is on most likely data analytics and data engineering. So that's where maybe right interested things for us here are uploading the data, and how do we go about maybe creating the notebook, creation of the query. Notebook is nothing but like our Python Jupyter notebook. In case you know about the Google Colab and all, so it is an interactive environment wherein you can write your maybe SQL code or the Python code, and so we will explore it. Okay, eventually. Queries is the query editor basically, right? So upon opening it, you should be able to write the query over there. Dashboards are like your Power BI dashboards and all, right? So wherein visually you can observe for different KPIs and all. And job is also important for us. It's about how are you accomplishing your entire data task end to end. And as part of our entire data processing, we can be having data pipelines as one of the major component. So that is our DLT pipelines here. And whenever we are executing our jobs or the pipelines, we may want to be alerted about certain conditions that may be happening. Maybe the job is failing, or maybe the job is taking too long. So about that we can get the alerts. So that stuff we have. And for version controlling of our work, we can utilize the Get. So Databricks provides the Git integration. And next up, we have here the SQL warehouse. This is nothing but the serverless service provided by the Databricks. Okay, so using this SQL warehouse, we will be able to run our queries and all. So this is the Databricks Express account that we are here, and if you get to observe, we will be having only the serverless features over here. So that's what you can observe from this compute option. If I hit upon it, you are seeing we have just SQL warehouses, vector search, apps and all is there, but okay, they are not provisioned by default. But SQL warehouse is by default provisioned, and we can simply go about starting this one. So this is limitation of the express edition that we have here. You can check through. You don't get to create your own clusters and all, right? So there is already the serverless warehouse provided for you. It's not the serverless cluster, it is a serverless warehouse provided for you. I'm mentioning it to be serverless cluster and serverless warehouse. So we will see the difference and all later. Fine, there could be some limitations upon what you can execute against the serverless warehouse and normal serverless service, right? Fine. Let us start it. Okay, they have given us the trial. Fine, and most likely $400 of okay usage we can do. uh, Depends on the kind of maybe right account we are using to set up the account, Databricks account. Fine. um, See, in no time we got the server up and running. It is available now. What we can do is we can go to SQL editor here. It is our SQL persona that we have. And I was saying, so this is how, right, you get to write your queries. Fine. So you can maybe click on the SQL editor and you can come here, but otherwise this quick option was there, query. So that also brings up your it opened for you one more editor, right? Query editor. Your queries can be named and all. So that's what these are editable things. So you can simply say maybe this is query one and this is our query 2. One second, query 2. Fine. And we can save these queries. There is save feature available to us, but while saving it will ask where would you like to save it. By default, right, there is one okay workspace given for us, uh, the default kind of storage location. I can simply say save it there, right? Now it got saved. Likewise, we can save our the other query as well. I will simply say save. Let us write a very simple thing. Maybe let us just say here select current user, right? It is going to give you the details or name of the current user. We have logged in, right? So that name we get to see here. So query editor, when you execute the query, you get to see the result below it. So it is a data test that we have here. Fine. So where is this happening at present where we are? If you look at right to the left side, the catalog is open. And this catalog, you are seeing it from here also. So catalog, as the name suggests, it is going to give you catalog of different data objects present in your account or the workspace. Fine. Workspace is nothing but the environment wherein you are going to keep all of your project related things. Fine. In the workspace, we might have created our databases, the tables and all, right? So all those you can search through this catalog. Fine. It's going to give you the list of all those things and navigating to them and so now by default you are seeing that uh, we have been provided with okay my organization and some delta shades received and all under my organization. That's nothing but the account, right? My organization is nothing but the account that we have created. Under that they have created something called workspace for us already. which happens to be the default catalog. Fine. So what is this catalog and all we will see later. This is where after entering into the catalog you are seeing some familiar things like the database and all. If you expand it further, uh, our tables and all should be listed here, but we don't have them because I didn't create any. So this is about the metadata, the information underscore schema. Under that you will be seeing that we have different views and all. So this is about metadata, so don't worry about it. Fine. Next we have system. This is again for monitoring and auditing and all, so we can just leave about it. So when it comes to we working with the catalog as a, common developer is that we will be creating the catalogs if at all permissions are there for us, but otherwise most likely it's like we will be having permissions to maybe query the data from the tables or creation of the tables depending on the role into which okay we have been maybe hired, right? So that's the case. And so with that now we mostly looked at the compute. So this is where you get the option of starting your server center. And next very important thing is a SQL editor. So this is where you get to write your queries and you can save them. And whatever queries you have saved, right, you can open them through these queries. You can see, uh, so I had created this one at so and so time, and you can click on it and you should be able to open it through the editor here. Fine. So what other options we have? We have your option of sharing. You can share your queries with your okay team members and all. We can schedule the query to execute at some point and so on. We have the options. So at this time, right, to get started, I think this info is very handy. Okay, so you got to know how to start your SQL warehouse. It's like the server being running. Once the server is running, you can write your queries and you can execute okay your queries over here using the SQL editor, and you can save them and all you got to know. So going ahead, we will be exploring upon how do we create the databases, the tables, and what are the different types of tables we have and all. Fine. Thank you. Stay tuned.
Welcome to my channel Data Test. As part of Databricks 101 series, now I will be discussing about Databricks SQL warehouses. Databricks SQL warehouse is the computation resource just like our data warehouse servers using which we can execute the queries. There are three types of SQL warehouse available in Databricks. They are serverless, pro and classic. Let us observe them from the Databricks warehouse. I am at the Azure Databricks and I am visiting the SQL persona. I am picking up the SQL warehouses. Here I get the provision of creating SQL warehouse. If I click on it, you could see here it is expecting name for the SQL warehouse, and next up it is asking us to choose the cluster size. Cluster sizes for the SQL warehouse decide its power, okay, how much capable they are at executing the queries. They are provided in the form of t-shirt sizes. Smaller the size you pick, lesser the power it is going to have. And obviously, right, so based on that the billing is also lesser. If you happen to choose 2x small, you will be charged 4 Databricks units per hour. In few minutes, we will be discussing about how the billing is done for utilizing the SQL warehouses. By default, X large type of the cluster is chosen and it is going to charge you 80 Databricks units per hour. And this SQL warehouse which you are going to create is going to auto stop after 10 minutes of inactivity. You have created the server, let us say, but you are not executing the queries against that server. It will check for 10 minutes. Within 10 minutes, if no query is received, it's going to auto stop. It will be terminated. If you don't that if you don't want that behavior, you can turn it off and your server will be running unless you stop it. But that's not the wise choice. Let us turn it off in case we are not using it. So here, as I was telling you regarding the cluster size, more the t-shirt size that you are picking, more powers you will be getting from the SQL warehouse. So if you would like to finish executing your queries quick, you should be increasing the size of the t-shirt here, that is size of the cluster. Likewise, if you happen to support multiple concurrent users, firing the queries against the SQL warehouse, you are supposed to increase number of such clusters required for your workload. Here you can choose the auto scaling option. By default, the number of clusters will be 1, minimum 1 and maximum 1, but we have option of choosing it. The moment I changed min to 1 and max to 10, it says it may consume from 80 to 800 Databricks units per hour, right? So this is per cluster, 80 Databricks units per hour per cluster. You are going for 10 such clusters, means it's going to be 800 Databricks units for all the clusters. Fine. The types you are observing here: serverless, pro and classic. When you choose about the serverless, the SQL warehouse which you are going to create will be up and running within no time, so the startup time is less. And likewise, let us visit and check out for the different options and differences we have with respect to these warehouse types. Here you can see, if you happen to choose the serverless, with the serverless we get the photon engine feature, predictive IO feature and IWM, intelligent workload management as well. But if you happen to choose the pro SQL warehouse type, you will be getting photon engine and predictive IO. If you happen to choose the classic, you will get only the photon engine. So what are these? Photon engine, predictive IO and intelligent workload management. Photon engine is the service that can speed up the query execution, and that way it is going to reduce the total cost per workload also, because your queries are getting executed quick. Predictive IO is the feature which will be helping you do the IO related operations wisely. Fine, it will help you speed up the scanning operations that query may have to do while fetching the details for your query. Fine, for example, predictive IO will be helping in optimizing the underlying file sizes and all. Next up, we have intelligent workload management. So this is something powered by AI, which will be helping in managing the workload very wisely, so that we are executing the workloads quickly and in efficient way, finally, which will help us in saving money. Cost effective solution it's going to provide us. So that's what those are the different features for our serverless, pro and classic. And depending on your workload, you can choose the required SQL warehouse type. Now let us take a look at what are the different kinds of workloads which we can execute using these different types of warehouses. Using classic SQL warehouse, we can execute ad hoc queries, and we can execute the queries that can populate the dashboards. We can connect our classic SQL warehouses to the BI tools like Power BI and Tableau. So overall, we could say, right, we don't have advanced features with classic SQL, and we can do lightweight analytics with this kind of SQL warehouses. We should be picking the Pro SQL warehouse when we have kind of consistent workloads which need bit of high concurrency. So number of parallel queries that we may be executing is high, means we should be choosing the ProSQL warehouses. So here maybe write some sort of fine tuning and all we have to take care for optimization. Teams running the regular reports and scheduled queries and all, they can opt for the ProSQL warehouses. The last option, the serverless, so it gives you instant startup and very elastic scalability. Within no time you will be seeing that server will be up and running for you. You can use serverless SQL warehouses to connect to your BI dashboards when you kind of expect bursty workloads. Okay, it is very unpredictable to know what kind of queries may be coming in. So at that time, serverless SQL warehouses are helpful. Let us summarize. When it comes to startup time, if you are using classic and ProSQL warehouses, they may take seconds to minutes, but your serverless SQL warehouse will be available within seconds. With regard to scaling, you may have to opt for manually controlling, or you may have to fine tune the scaling aspects using the classic and ProSQL warehouses, but in case of serverless, it is fully automatic. Concurrency is configurable with respect to the classic and pro, but with the serverless, depending on the workload that is coming in, it is elastic in nature, so accordingly it will be adjusted. Coming to the cost, the SQL and classic warehouses, they are better for steady use, wherein kind of you have the predictable workload. That time we can go for SQL pro or the classic type, but otherwise if you don't know the pattern of the queries and all, it's better we go for serverless warehouses. When it comes to working with serverless SQL warehouses, we need not fine tune anything with respect to the cluster management and configurations. Here with SQL warehouses, we may have to take care of fine tuning certain configurations and all. So with that, today we learned different types of the warehouses and all, and here is a quick summary of the different cluster sizes that are available, and the power that comes with each size. For example, this XSmall will be giving you 2 virtual CPU cores with 8 GB of the memory. If you happen to set up your SQL warehouse with this XSmall size, you can, right, at any given point of time, can execute 10 parallel queries. So that is a concurrent slots that is listed over here. So if you happen to have very complex workloads and all, it's better you go for larger size. And if you expect more number of users to be connecting to the cluster, increase the number of clusters. So this is a final summary. And next up, let us look at how is this Databricks charging us for SQL warehouse usage. We saw that they have normalized billing in terms of Databricks units. For regular workloads, they will be charging around 0.55 per one Databricks units. But how many Databricks units we are going to consume? Let us say we have a job, and that job may be consuming one Databricks unit per hour. If that job is going to run for 10 hours, we can compute the total billing this way. Total cost will be the Databricks unit rate, which is nothing but this one, into how long you are running your job. For this case, okay, for the job which is consuming one Databricks unit per hour, running for 10 hours, the charges will come around to be 5.5 US dollars. In Indian currency, it's going to be around approximately 500 rupees. Fine. So thank you. That's all for this video. Stay tuned for next topics.
Hi everyone, welcome to our channel Data Test. As part of our Databricks 101 series, today I will be discussing about Databricks object hierarchy. This is the sixth video in the series. If you have not checked our previous video, please do check it out. Let's get started. Traditionally, working with our RDBMS, you will be quite familiar that we will be creating databases, and within the databases, we create the tables, views, stored procedures, and so. So you can observe that kind of similarity here with the Databricks object hierarchy as well as part of the hierarchy. Schema is nothing but our database. Within the database, we can have tables, we can have views, we can create functions. Apart from that, in Databricks platform, we can also create one more type of the asset, which is called as volume. Mostly, we are comfortable with this hierarchy. But then Databricks provides us two more layers or levels on top of this database. One is catalog, the other one is metastore. Metastore is top level container for storing metadata for all our objects we create in Databricks. Apart from what I have highlighted, you are also observing here that in parallel to the catalog as siblings, you could also see some entities like service credential, storage credential, external location, connection, share, recipient, provider, clean room, and so. Going ahead with our series, we will be discussing what these and all. As of now, let us try to get some heads up. Metastore is a top level container, as I was mentioning. But as a data engineer, data analyst, or maybe ML engineer, we may not be creating Metastore on our own. Metastore is usually created by the Databricks account admin. And this provision is available only through the account console provided by the Databricks. But all other entities that we are seeing here, they are accessible from the Databricks workspace. Most likely, whoever is working with the Databricks, right, they will be having appropriate permissions to log into the Databricks workspace and work with the different data objects over there. Let us try to have a look at some of these objects available. One second. Fine. I have opened my Azure Databricks. One second. I have opened my Azure Databricks and I'm using the uh, trial version of Azure Databricks. And over here, by default, we could see that this workspace, which I have opened, is Unity Catalog enabled. What is this Unity Catalog enabled? We will explore upon in the next series. But then, as of now, we can focus upon what different objects we get to see in the catalog menu of the workspace. We have the catalog here, and navigating from the catalog, I have opened it over here, and you can see the different things that you observed in the PPT, right? The delta sharing option, the clean room option, external data, add data, all these you are able to observe over here. If I open this delta sharing, you'll be seeing we have options like shared with me, shared by me. Yeah, shared with me. If some people are, organization has shared some data with you, right? It will be visible over here. They're providing the data to you, so that provider information will be available over here.
But in this free edition, we don't have proper privileges, so we don't get to see them. Likewise, if you go to shared by me, here you'll be seeing with whom you have shared the data. And that recipient details you should be registering first. So we have provisions here for registering the recipient and all. Likewise, if we look at this external data, related to the external data, we have few more details. The credentials tab is there, connections tab is there. This credentials is like storing access keys for your storage. Most likely, you will be keeping your data in your cloud provider. Over, for example, if it is Azure, we can say you'll be keeping it in the ADLS. So access keys related to your storage account you'll be storing over here. Once you have stored your access keys, you can store information about the location where you are keeping the data here by creating the external location. And while creating the external location, it will be asking you to mention the access key for that location. So that way, storage credentials are important for us. Sometimes we may be creating direct connections to, let us say, SQL kind of the servers and all. So those details will be storing over here. It will ask connection name, connection type, and other additional steps and all it will be asking for, wherein server name, the port number, username, password, all those, right? We can store across. So this is about some of the important things like storage, credential, external location, the connection, share, recipient, provider, clean rooms and all. Likewise, we will be storing information about the service principal and its credential. Fine. Okay, that is cool. Now let us focus upon this hierarchy. Metastore, it's not visible to us. It is by default created for our free trial. And below that, you could see uh, by default a catalog is created for us. Okay, for every account a catalog is created by default. In that catalog we'll be having the databases. So this is the catalog. Just hover the mouse on it, you could see this is the default catalog which is having same name as that of the workspace that I have created in the Azure Databricks. And in that catalog by default we have default database, nothing but schema and information schema. And system related catalog also we have, which is used for storing the metadata related to our data objects and all. Likewise, by default, Databricks will be sharing with us some sample uh, databases and tables and all, which will be coming here, but we can't access them unless we have the data warehouse. So they're not visible to us. So this is, with that we got all that access. Like we can browse through Metastore, catalog, schema, tables and all. Are there any tables by default? Let us check through. Uh, it's empty, right? Catalog, database, and there are no tables. But what is this other thing that we are seeing? So this is nothing but the legacy Metastore. For our Unity catalog, we are creating Metastore our own. Uh, but this was something previously supported by Databricks. But as of today, Databricks is recommending us to use Unity catalog service. Fine, and this will be soon decommissioned by the Databricks. Fine. So this is what we see. Let us quickly create maybe a few tables here. We may not be able to create the catalogs. Again, we need compute for doing anything here. Let me check through if I can create quickly a SQL warehouse, very small one. Okay, let me say start and let's go to SQL editor, or otherwise we can do it from UI as well. We have that provision. Catalog we can go to, and here let me expand upon this catalog, and we have the database here. And here we get the provision of creating the table and all, we can say create table. Since this is the free trial version that we are using, we could clearly see that we don't have permissions to create catalog with the default metastore location. It is further asking us to uh, create our own location in the Azure data lake and provide it here while creating the catalog. Fine, anyway, let us try maybe at least creating the database. Create database and let's call it as new DB. This should be working fine. Yes, we got it. And it is created over here. We can clearly check it. Let us switch to this DB, whatever new DB we created. We are in this catalog and let us switch on to DB. And here within that database, let us create table, right? Let us call it as create table and let us say maybe student and let us just store name of the student. Fine. This should be working good for us. And here, let us insert a few records as well. With that, we are good to go. It says new DB already exists because we already executed it. Let us retry. This is commented. We are giving one more try. I think now we are good. We can see here new DB student and there is the column there. From catalog, you should be able to even see the sample data. So with that, today you explored upon the hierarchy of the data objects within the Databricks account. So we'll be having the data objects, and to access those data objects, we may be using certain data assets like workspace, notebooks, or it could be queries, or it could be some other files and all, right? Further going ahead in my next video, I will be discussing about what are the different types of the tables we can work with in Databricks. Stay tuned. Thank you. Hi everyone, welcome to my channel Data Touch. As part of our Databricks 101 series, today I will be discussing about Databricks views. This is the 8th video in our series. If you have not checked our previous modules, please do check them out. Let's get started. What are Databricks views? Have you wondered how massive teams across the departments will be sharing real-time insights without duplicating data or without breaking pipelines? The secret lies with how you define your Databricks views. Databricks views, much like the views in RDBMS, are the virtual tables which store no physical data. Most likely, it will happen that we'll be having certain tables in our Databricks. Let us say here table 1 and table 2. Our data analyst may need data from table 1 and table 2 in a certain manner. That's when we can write a query that may join the records from T1 and T2 and result of that query can be saved as view. That way, the views are virtual tables which which are going to just store the query text in the Databricks. Remember, for views, only the query text, which is used for creating the view, will be stored in the Databricks metastore. When you happen to query the view, the underlying tables will be queried to fetch the data. So if this is your view, this would have been created with some select statement. So when you fire a query against this view, in turn, the data is actually fetched from the underlying tables. This is a very crucial aspect here. Fine. So then what are the different types of views we have in Databricks? In Databricks, we have, I could say, roughly 6 different views. First one is a normal view. Second is temp view. The third is variation of the temp view, which we call global temp view. Fifth one is materialized view. Sixth is lateral view. And last one is the dynamic views. We will talk about each one of them and we will see through the hands-on how they are different from each other. Before I proceed to the hands-on section, few important points for you. The global temporary views are a legacy from the Hive. So Databricks doesn't recommend using the global temp views. And these global temp views are not supported in the SQL warehouses. Second important thing is the lateral views are deprecated as of Databricks 12.2 version. They are still useful and being used by the developers in Hive and Spark, but in Databricks, okay, it's not recommended to use them. Instead, we can be using the table value generated functions. The dynamic views are something that we can use in conjunction with Unity Catalog for controlling the access to the data of the tables. We can apply control at the row level and the column level. We can use the dynamic views for redacting. For example, certain personal information is there, then that data we may have to redact it or mask it for certain category of the users. That can be done with the dynamic views. Fine, let us look at the hands-on now. I'm in my Databricks workspace. I have opened a notebook and I have connected it to the cluster. This happens to be the serverless cluster. I'm using it. Let us see how the views are going to work. First, I'm considering the normal views. As I told you, mostly views are created from the existing table. Let us create a table quickly. 1 second. Create table SC as select star from values. Let me say simply two values here. One the name, second is the mail. As name, comma, email. So this way we can provide quickly some content onto our table, right? So with that, we should be creating the table now. Create table st as select star from values. So let us check on it. Yes, the table is created. Let us check the contents of it. Here, we should not be using quotes. It is just the names of the columns. Fine. Let us check here. Select star from st. Let us do. We can see that the value is inserted into it. Let us create a view now. See, for the table that we have created, we should be having the table created here. Let us refresh. ST table is created. We can observe it from the catalog. Let us create a view now and see whether it will be listed here or not. I'm going to new cell. Let us say create view. Create view ST view, I will say, as select. Let us get uppercase of the name. Fine, and email as email itself from ST. Fine, create view. The view name ST view as select upper of the name comma email from ST. Let us do it. Let us execute. It's done, and let us refresh and check here. What's happening? Even we have entry for view in our catalog, just like our table. Great. But then please remember only the query text. Only this definition is stored in the meta store. Actual data is not stored. Fine. How can we fetch content from here? We can say select star from st underscore view. Correct? Fine. Let us execute it. Okay. Typo. It is W. Let us execute. Fine, it's done. And you could see that we have the name in uppercase. What will happen if the new data is inserted into the table? Let us insert a few records into the table, maybe one record. Insert into ST values. Some data. Let us insert. Let me just select and execute this. One second. Fine. The record is inserted now. Let us check what happens to the content of the view. When we queried the last time, it was giving only the first record to us. Now we have updated our table, and if we do select star from the view again, you can clearly see our view will be fetching the latest data as well. It's because it is just the definition. When we execute query against the view, the data is actually fetched from the versional table. So this is clear. And these views exist permanently in your Databricks Metastore. Even if you detach this notebook from the cluster or the warehouse, it will be still there. Let us check it out. Let us detach it and reattach it. Detach will happen and then we will be reattaching. Even after that, if I execute query against my view, I should be seeing the result. Yes, it is there, clear. So that was our normal view. Let us create a temporary view now. I will pick this same old previous definition. I go to the new cell. Here, I will simply make small changes. I will say create temp view. I will call it as stTMP view. Content wise and all, let us keep it the same. As of now, we have two entries in our default. One is ST and one more is ST view, that is table and view are there. Now we are creating the temporary view. Let us observe what will happen to this hierarchy. Let us refresh. Do we see entry here? No. So for a temporary view, no entry is created in our catalog. But if you tend to query it, it should be same like earlier one. But then what's the difference? The difference is with respect to the scope. How long they will exist. The temporary views are existed only in the active session or the active notebook that we have. Let us check the result now. We have the data, well and good. Let us go for checking the tables, show tables. Let us say this cell, let us change it to SQL. It says here we have few different tables and all of them are in default. SC is a table, ST view, but they are not temporary in nature. That's why false we have. But this temp view, right? Is it temporary in nature? Yes, it says. Fine. Good then. Now, to understand the scope of this temporary view, let me detach this notebook from the cluster and reattach it. Detach and reattach we are doing. Fine, it happened. Let us query that temporary view again. Or before that, let us check the tables as well. If I check for them, those temporary table, right? It's no not there. And obviously, right, if we go for executing query against it, we will get nothing. And there is error because that view itself doesn't exist. Fine. So that way, these temporary views have very less scope. They will be accessible only within the same notebook. And if you change the notebook also, you can't see them. And if you detach and reattach the notebook, again, they are gone. So that way, they have very limited scope. Fine. Next up, let us see the variation of the temporary view, which is nothing but global temporary view. So over here, I will just make small changes. Create temp view. In front of the temp view, I will have here one more global temp view. Create global. So this time, to create a global temporary view, you have to just add the global keyword. I will make it as GTMP. Fine. And let us execute it. It says these kind of views are not supported in serverless compute. This is what I was mentioning you earlier. Fine, we can't define global temporary views in the SQL warehouses and the serverless. Serverless are serverless compute is powered by SQL warehouses, so we don't have it. If you happen to work with your general compute, you can check them out. It should be working fine for you. Or otherwise, let us quickly check them from the community edition. For showing you the materialized views, I picked up on the serverless compute. It may take a while. Let me just spin up this cluster. While this happens, right, we will continue with this previous discussion. Right? This global thing won't happen here, so we will test it out from our community edition. Rest of the other things, let us explore upon. Let us see now about the lateral views. So lateral views are something that we will be using to work with kind of, the complex data. I took the simple example earlier, right? For now, let us say I have a table, something like this, which is involving certain, uh, I could say, complex data. Okay, so I'm instead using the view, create or replace temp view users as select star from values. And you could see here, I am inserting the complex type. So it is array of email IDs for a given user we are using. So that way I'm creating a view which is going to have two records. Now, while working with this view, let us see how we can actually break out the contents of this complex column. Select star from users. If I say, we should see that we have here emails as array of strings. If you expand, you can see the contents for each cell is nothing but array of elements, right? So basically our column is of array type having strings inside it. So how do we go about fetching the data from this array? So that we are extracting the individual elements. What we can do here is I can say select name, comma, email from users, and I can say excuse lateral view explode. What's our column? Our column name is emails. I have to pick your emails. So this is going to give us lateral view, the exploded version of it. Let us call it as T, a kind of a very virtual temporary table that is there as email, right? The individual elements we bring out of after explosion is the email and the same one we are picking here. So this way, if I go about executing it, you could see that this time we have it splitted. Fine. Earlier, against allies, we had array of emails, but this time each element is present in its own row, correct? Uh, so allies is repeated twice, and for each of the element in the array, we have the row entry here. So this way, lateral views are helpful while working with the structured data, but this is a legacy, and Databricks doesn't recommend using it. Instead, what can be done here is we will remove this lateral view part. We can remove this off as well. And this method, whatever we have, we can put it across here itself. Okay, and we will remove this. So this is what we should be doing, and it gives us much readability also, right? So that's what Databricks says, get rid of the lateral views and instead just use the table value generated functions like this to improve upon the readability. So with that, we are done with these uh, lateral views as well. Next, what we have is a materialized view. And in this materialized view, let us try to create here and check if it is going to work. So create materialized view as, let us keep the definition same as above. I will share across this notebook later for you. You can check it out from my GitHub account. Fine. Create a materialized view as select uppercase of the name and email from ST, let us say. Let us see what will happen. Will I be able to create them in the notebook or not? Let us observe it. Materialized views, basically what they do is, as the name says here, for example, let us say table is there, and out of that we will be creating a view, right? 1 second, we'll look at that later. So let us say when we created the materialized view, there were 3 records here, and you wrote some logic here, and accordingly, the data is actually fetched. Okay, data is actually fetched and stored. Okay, for the materialized view. That's why it is the view which has the data, which is materialized. They are like tables, but then they are derived from the original table. Okay, they are like tables, but they are derived from the original tables. Fine. And data is already pre-computed and they do have the physical data with them. So that whenever we query against the materialized view, again, this query need not be executed. Fine, it is pre-computed and we will be getting the data very fast to display our dashboards and all. Fine. Let us look at what is the issue here. Create a materialized view as select from ST, but ST we do have it, right? Let us check upon it. It says tabular view ST cannot be found, but we do have it. Let me give the complete name otherwise. Let me check this here. That's all. We have it as a workspace and here, right? We can try to insert its name. Fine. Let us check upon now. Please feel free to fast forward this section. Fine. Uh, you could see that materialized views are something that we can't create within the notebook. Let us give a try from the SQL editor. We have the SQL editor here. Same thing, I'm just copying, and here the editor is open. I will put across the same statement, create materialized view as so and so. Let us start the serverless warehouse here. I may need to start it. It's not up and running. Let me go to compute and check what's happening there. It is there, but it is in stopped state. So let me start it. Yes, very quick, right? Serverless one. We got it up and running in no time. It may take a while because I'm using the personal edition of the Databricks. We may have lesser computing and all. For materialized views, it may take a while for this to set up. Now you could see that this operation is successfully executed. Are the materialized views stored under here? Uh, excuse. In the catalog, let us check through. You could see that we do have, what's the name I have given? Name I didn't give. So it became AS, right? Create materialized view. I should give the name here and then I have to say alias. So this is our materialized view. You can observe here. Materialized view is created. We can try to fetch data from here. Let us check upon. Let me make some room and let us say select star from as AS, correct? Will this be fine? Let us check upon it. Great, we got it. But then let us insert some record into ST and check what will happen. Insert into ST values and let us give some name and mail ID here. Insert into ST the values, comma, right? So let me execute the insert query first. Done. Let us query our view now, the materialized view. To execute the individual statements, you should be highlighting it. Those three statements are here. I just want to execute this one, so we will be highlighting and we will be fetching. So what do you observe here? Our table has three records now because I've inserted one more record into the ST table, but still my materialized view, which we created earlier as of the previous version of the table, had only two records. That's why we don't see the fresh data. So how do I go about updating my materialized view? For that, we will be doing refresh materialized view and we will give the name of the view and let us check it. It says that operation is successfully executed. Let us try to fetch the content from the materialized view now. You can see we have the updated data. So this way, materialized views can be refreshed using the refresh command. So with that, we covered upon the normal view, temporary view, materialized view. Let us look at the global temporary view as well. One second. Let me go to my community edition. Here, we tried creating the global temporary view from the serverless connected notebook and it was throwing error. Let us try to create the global temporary view in our community edition and see what will happen. But this table also I don't have, so I have to quickly replicate upon the table as well. So let me grab upon that information too. Great. One second. We'll do it quickly. Create table. And out of that, we are creating the global temporary view this time. Correct. Let me connect it to the cluster. Cluster is up and running. Let us execute it. Hopefully, this should be working fine. We should have the global temporary view created for us. But do we see it here? In the community edition, the kind of catalogs you see, okay, they will be different. Instead of the workspace catalog or some other catalog, we have just one which is called as Hive Meta Store. It is still working upon it. Let it happen. Fine. The view is created for us, but then, okay, it's not listed in our catalog hierarchy. Only ST is there, which is a table, but we don't have this ST global temp view, right? It's not listed there. Then how do we go about querying this view? Let us first execute the show tables and see if it is listed for us. It's the Python cell. So we should have here the SQL cell. Great. It's not listing, right? It's not listing in show tables. Then where is it created? Let us check something like show tables in global underscore temp. Fine. Let us check upon now. You could see that these global temporary views are getting created in a specialized database called global underscore temp. And these are also temporary in nature. But how different these are from the normal temporary views? We will check upon it. Let us try to query the contents of it. It should be same as the any other query statement against the table or the view. But we have to remember that these global temporary views are created in global underscore temp database. So we have to mention it. Dot, okay, student global temporary view. So this is the way we have to query the global temporary view. It should work and we will be getting the result. What you have to understand here is that if you detach the notebook from the cluster and if you reattach also, it is detached now and let us again attach it. Blue circle, now the green circle. Correct? It is attached again. If I execute the query, or otherwise if I check through whether it is still present in the global temp database or not, what do you think? It is still there, right? So though you detach and attach the notebook, we still have this global temporary view in the global temp database, right? Likewise, this this global temporary view will be accessible from the other notebook also. If you just create a new notebook and if you happen to execute this query in that notebook as well, we should get the result. But this didn't happen for the normal temporary view, correct? I hope you remember that. Yes, it is still working. So it has broader scope compared to the normal temporary view. But are they same as the normal views then? No. If you stop this cluster, right? If you happen to restart the cluster, the global temporary views are gone. So they are scoped at the cluster level. Okay, they are tied to the active cluster, and if you restart the cluster, they are vanished, right? So this is the difference we have. So with that, we covered upon the different other view, that was the global view. Now what we have, the last one is the dynamic view. Dynamic views are something that we create for controlling the access. Let us quickly take one example. I think the time is getting extended. I will say here, okay, a simple view to be created like this. Let us check upon it. Fine. Let me go to the editor, SQL editor. What are we doing here? Let us take a look. Create view, mail redacted view as select the name, upper name. It is the uppercase name, right? That's why I have given it as uname. But then observe. So based on the user who is accessing the view, okay, we are going to restrict the content displayed for a given column. Here I have hard coded, but we have better ways of doing this. Dynamically, we will be fetching who is the current user, and we will check whether that user is member of certain group or not. If he is member of HR group, then he could see the email properly. If he is not member of the HR group, we will be just maybe restricting. Let us say if he is the analyst, we don't make him available of the entire mail. Maybe we will just give him the domain part of the email. So that way we can restrict it. So this st underscore view, we have it right. It's here. The name is different. So let me just update it. So it is just st underscore vw. Fine. Let us check upon it, and the names also. Right. Let me just insert it here. The names are different. I will insert the column name, which happens to be the, okay, we can rename it if required. So here, if left hand side and right hand side are same, the contents of the email should be as it is. But otherwise, we are going to extract only the domain part of it and we will expose it as mail column, right? Let us execute and check what will happen. There are some errors, it says. Just a second. Let me just fix it and I will. The comma was missing after the first column. And now let us see, we have the result here. Left hand side is equals to right hand side. That's why we see the mail as it is. Let us deliberately introduce some mistake here so that this clause is not okay executing to true, and we should be getting the else part. This view is already there. So fine. The select star query, right? I didn't update it. It is view 2 now. Let us select upon and execute it. You could see that we don't have the complete email address this time. Okay, so with that, all the different types of the views are completed, but we should be avoiding using the lateral views and global temp views as much as possible. And all other views are quite important for us. The materialized views, most likely, right, we tend to use them in our ETL pipelines, which are powered by the Delta Live tables. We will discuss upon that in the upcoming video. Thanks for watching. Stay tuned. Hi everyone, welcome to my channel Data Test. As part of Databricks 101 series, in this video, I will be discussing about Delta Live tables. This is the ninth video in the series. In case you have not checked our previous videos, please do check them out. Let's get started. Every data engineer would have spent amount of time dealing with the messy data pipelines, fixing broken jobs late at night, chasing the unexpected errors, and worrying about data qualities. Really, working with the data pipelines in the traditional way is a hectic job. With that came now the very huge upgrade from the Databricks, that's the Delta Live tables. With the Delta Live tables, you can build both streaming and batch pipelines with simple declarative logic. You get auto-managed infrastructure and built-in data quality checks, and you can end-to-end track your pipelines very nicely. That is, DLT, Delta Light Tables provides lineage for the tables that you create. Let us check them. The the Delta Light Tables is very crucial because when we start building the data pipelines, the data ingestion begins getting the data from multiple sources, easily from tens of sources to maybe hundreds of sources. And from each source, we may have uh, tens of, again, tables to hundreds of tables, and each table being hosting maybe thousands of columns or so, right? It's not very uncommon with these numbers. When you happen to start building your data ingestion pipelines and then about the ETL pipelines with these data sources and the data in hand, it is very common that whole of the architecture begins to be complex, and you will be creating new tables from the existing raw tables, and from there again a few more tables. So that way you will be having set of upstream tables and set of the downstream tables and all. So when something goes wrong, or when you would like to observe closely how the data is flowing between your tables, without a very nice framework in place, doing all of this stuff manually or by maybe integrating certain tools that are available in the market is a tedious job. So that's where Delta Live Tables can save us. Let us look at how it can help us build pipelines. One second. Let me navigate to Databricks Workspace. I have created very small script here. This is very much essential for creating our Delta Live Tables pipeline, DLT pipeline. A script is required in which you will be telling what you would like to do with the data. Using that script, you will be creating a pipeline. Once the pipeline is created, you will be executing the pipeline. So, three steps: create script, build the pipeline, and execute the pipeline. Here, for understanding that to getting started, right, as a beginner, Simple things I'm considering. I'm creating here two tables. First one being the streaming table. Streaming table is nothing but the table that can grow as the data is incoming. Let us say we are trying to read data from a folder here called as logs. Initially, it could happen that in that folder we have just one file, and later, maybe hour later or 2 days later, new file will be arriving in this folder, and our streaming table will be capable of detecting that file arrival, and the records will be inserted into the table. Those are the streaming tables. Fine. So that's what basically we are trying to do here. I do have this folder already created in the catalog. Let me just try to open it up. Here, catalog default is the database for me. Logs is the volume. Volumes are nothing but just like folders. Right? They contain unstructured or semi-structured data in the form of the files. That's why we can call them to be volumes. We have discussed it in our data object hierarchy as well. So in that volume, you could see that I have this file. But here, the location for my table, I have mentioned it to be the folder. So whatever new file arrivals are going to happen to this folder, our table will be detecting it. So this is our first table, which we are trying to create as part of our DLT script. Next up, deriving from this table, I'm creating a materialized view. Materialized view is nothing but a pre-computed result, correct? What is that pre-computed result I'm trying to do? Some sort of group by operation and aggregation count. So level wise, we are trying to see here how many number of logs are there. Basically, I have here logs data. Fine. So that content is not important here. Let us focus on how does this DLT look like. So this is our script just with two tables. This script I should be submitting to the pipeline. But where do I have the pipeline? I don't have it. So we have to create it. From here, we can navigate across workflows, the pipelines option we have. Then we go about create pipeline. Let us pick up on this ETL pipeline. Maybe later, let us say for that, let us call it as my PL, my pipeline. How would you like to execute the pipeline, the data pipeline? Triggered. Manually, we will execute it. So I've chosen triggered. And here, while creating the pipeline using the script, you are submitting using UI, pardon. You are submitting your script here, paths. Browse to the location where you have the script. It is in the workspace users. That's nothing but our notebook, right? So let us select it and it's done. You can simply say here, create. Did we miss anything? Yes. I'm trying to use your serverless compute for my data pipeline. Important things is I should be choosing the catalog here. I will choose it to be workspace, which is there by default. And default schema also I will choose it to be default one, which is there for me already. Fine. With that, we can simply say create now. So this is our second step. Script was ready. With that, we created the pipeline. You can't see that here in the visual form. We will get to see it once I click on this, executing the pipeline start. Nice. Since it is a serverless one, we should not uh, face here much of the delay. It should be up and running in 1 or 2 minutes, which otherwise would have taken with the traditional compute clusters of the Databricks around 10 to 15 minutes, especially right when we are in the development phase and all, we tend to choose the cluster with a single node being maybe right having 4 GB RAM and one CPU core and all right. So that would have taken time. Hopefully, I believe here, yeah. So we didn't wait much of the time. So it is initializing, it is trying to set up the tables. If at all some issue happens here, we will be notified. So there are event logs that are generated corresponding to the different operations that may be happening through this Delta Live tables. We could see that it is actively running, and since it was very simple script, right, our table one is successfully created. It is a streaming table. And second one also we are done with. It is a materialized view. Please take a look at the different icons that are being used uh, for this streaming table this way and the materialized view this way. Now you can clearly check out from the catalog. I'm in the catalog, the workspace. Let us refresh it. In the default database, we could see we have two tables here. Fine. One is the streaming table. The other one is the materialized view. So we would have created these tables separately, but tracking through them is a manual effort. So we are doing with the help of the DLT framework, which happened with the creation of the pipeline and all. So with that, you can see the DLT automatically detected that the materialized view is depending on the streaming table. We could nicely see that flow being happening here. So with that, we are getting here closer observability onto how the data is flowing between the tables. And you are seeing here that into the streaming table, we have read successfully 13 records and so on. And this is the materialized view, grabbing the details from there, which is doing just the kind of aggregation. Fine. If individual table details are required, you can check through them. Since it is a Databricks 101 course, in the interest of the time, I'm cutting short the detailed view of it. We will take them up in our Databricks 201 course in length. Fine. So the tables are ready. If you would like to check them, whether really we got the updated result or not in our materialized view. I'm just opening the SQL editor. We have our tables created and all right. Let us try to fire a simple query. Select star from logs underscore um, MV. That's the name, I guess, that we have. But I don't have the SQL warehouse up and running. Let me go to compute. I'm using the Databricks Express edition. I'm coming to compute. Let us start the SQL warehouse. Great. I should be up and running in a few minutes. Then we should be selecting and attaching our editor to this serverless warehouse. After that, I should be able to execute it and check it out. It should give us the log level information. Okay, how many info logs are there, how many error logs are there, and so right. Seems like we have one null as well. So this is the thing. Now, what will happen if a new log file is landed onto this folder? Correct. So this is my folder, the volume. Um, Let me upload one more file onto it. Let me just choose upon uh, some file with the same schema I'm uploading. So what just happened? Our source folder got new entry, new file arrival happened. Then how will my DLT Delta Live table detect it? Right. Here we have chosen it to trigger our pipeline manually, but there are provisions for triggering it automatically as well. Since we know that there is new file arrival, I am triggering the pipeline execution again. I will say start, but this will do incremental data loading. It's not going to load our previously loaded file. It is just going to load the newly arrived data this time. It is just exact copy of the previous file. So that's where you could see again 13 more records being written. And it is now executing the aggregated query. Meanwhile, let's go to editor and let us try to run it. We should see the updated results. So with that, you can clearly see Delta Live Tables is giving us um, better observability into the flow of the data, okay, in the pipeline. And for some reason, right, if some mistake is there, if some errors are happening, let us maybe try to induce some error into our script here. This is my script, and deliberately let us induce some error. I will put across maybe error on to the folder. Fine. Let us check how it is going to behave. Right. I will execute this pipeline again. Where is our pipeline? It's here. Let me say start again. It is failing, right? Initializing. There itself we have error. Let's go to view logs, which is the event log. It says something here, right? Just click upon that. It says the volume workspace default.logs one does not exist, right? There is nothing like logs one. We don't have that volume, so it is complaining about it. So this way, okay, debugging and tracing our errors is easier with Delta Live tables. So that's all for this video. In the next video, I will be discussing about the workflows. Thanks for watching. Stay tuned. Hi everyone, welcome to my channel Data Test. As part of Databricks 101 series, in this video, I will be discussing about Databricks workflows. This is 10th video in the series. If you have not watched my previous videos, please do check them out. Let's get started. What are Databricks workflows? Let us try to understand it with one real-time example. Let us consider retail sales use case. Imagine that you are working for a retail company that sells products online and in stores. Every night, you need to collect sales from different sources. You have to transform the data, generate related reports and dashboards so that your managers can take a look at it and send alerts if at all sales are dropping below a certain threshold. So, how can we achieve it efficiently? That's where we can bring in Databricks workflows. This can be achieved by writing scripts, maybe in the form of the notebooks. We can have here 4 different notebooks, one for ingesting the data into our Databricks platform, one more for transforming the data, yet another notebook for generating the reports, and one more which covers the logic of sending alerts to the required stakeholders. So script, this is all is a script. We have to keep it ready. Once the scripts are ready, we can go about creating a workflow, which is nothing but a job. We can navigate to workflow menu and there some UI options will be there, and we can go about adding these different notebooks as different tasks of our entire flow, which needs to get executed one after the other, right? Once you set that up, you can schedule that entire flow so that every night at midnight, the entire flow gets executed. It's going to pull the data, it's going to transform it, and generating the reports and notifying the stakeholders as well. And apart from that, you can constantly monitor across whether the jobs are failing, what is the status, if at all the tasks are failing, how can you retry. All that is possible through the Databricks workflows. In simple, imagine it like every day at the midnight, you, with the help of the Databricks workflows, pulling the data from the different sources, transforming it, generating the reports, and telling your boss about what's going wrong, all automatically while you are sleeping. So that is the easiness or the streamlining thing workflows can bring us in Databricks. Let us get started and try to understand it with one very simple example here. For this demonstration, I have kept my tasks ready. I'm going to use 2 tasks from the notebooks, and I will be using my previously built Delta Live table pipeline as one of the tasks. If you're not understanding, please hold on. Maybe once the flow is completed, it should make complete kind of, overall sense to you. Here, I'm naming one notebook as task 1. It is doing very simple thing. I'm just checking if there is a certain table and I would like to drop it. Fine. Once I take care of this, I would like to trigger my Delta Live table pipeline, DLT pipeline, which I have demonstrated in the previous video. After that, as part of the DLT pipeline, we are creating a materialized view. And as task 3, I would like to display the contents of the materialized view. So this is what we have. Let's get started. I'm at workflows menu, and here creating workflow is nothing but creating the job here. So let us say create job. You can give a nice name to it. Here is the name part. Let us call it as my job. Fine. Our job will be made up of multiple tasks, right? Pulling the data, transforming it, generating reports, and all we discussed. So here I'm keeping it simple. I'm creating task one, which is about dropping my table. I will call it as task one. It can be anything. Okay, your job name can be anything, your task name can be anything, but name them appropriately so that you understand yourself better in the future and your teammates as well. Some standards needs to be followed upon. Fine. So what's the kind of the task? The kind of the task is a drop down option here. Your script may be there in the notebook, or it is a simple Python script, or it is a wheel file. It can be your query, right? It can be your DLT pipeline, or it could be your DBT, right? Or it could be other job. Okay, job inside the job. It can be a dashboard. It can be some lightweight programming. All that possibilities are there. In our case, notebook is the task one for us. From where we are getting the notebook? From this Databricks workspace itself. Then it will ask, what's the path of it, right? Let us click on and select upon this task one notebook, confirm it. Let us scroll down and we are going to create this workflows using serverless. Let us keep it untouched. Again, after that, you are saying if at all some libraries we need to add, we have provisions for it, but this is the trial version. I don't get options for. We'll check on the details in our upcoming videos. Fine. I can simply say here create task now, and task is created. And if you want, you can zoom in and check the details. Once I'm dropping the table that is existing, I would like to go about executing my pipeline, DLT pipeline. So I will say add task, but it will ask me what kind of task it is. It's going to be a pipeline. So I say pipeline, DLT pipeline, right? I will call this as task 2. Now type already populated has pipeline, and we should be picking the pipeline that we have created. It's the myPL. Fine, I have chosen and automatically detected from the design that we are doing. Task 2 is depending on the task 1, correct? And then we should proceed to execute it only if the previous ones are successfully executed. At this point also, if you want to notify someone of the different status of the task, you can set it. How many times you would like to retry before giving up, and certain other thresholds like what is the expected duration of the task execution. If it is taking more than that, you may have to time it out. So you can set through the metric thresholds option. Fine. Let us say create task now. With that, as of now, our workflow has two tasks, task 1, task 2. Dropping the existing table, then proceeding to create tables through the DLT pipeline. Let us add one more task, and this is about querying the content from the materialized view, which I will write it in a notebook. So I will take it to be notebook type, and this is my task 3. Fine, type is notebook. Let me select it. It is our task 3. I will just say confirm. Fine. Other options are similar to what I explained earlier. Let us say create task. Well and good. And now certain details are there. Please do observe them when you practice. And let us simply say now run, right? We created the job, that is well and good, but we have to execute it, right? Once the um, job is designed. So this is how our overall job is looking like. Did I execute run now? I think we clicked on it, but let us see. Let's go to runs. Is that happening? Yes. It's the run one, right? Job is created, but we can execute it as many times as we want. Okay, just like maybe when you're trying to prepare one uh, recipe, right? You may be giving multiple trials, okay, depending on the result, the outcome, right? So you can think of this uh, run of the job as one experiment, one trial that you are doing, right? So it's the first trial, first run we give for our job. and it is showcasing the progress. Here, individual task breakup is there. So task one and its related details. It is in running state. Serverless is available. Likewise, if you look at task two, it is in blocked state because it is supposed to get executed after task one. So it is in blocked state. Likewise, task three is also in blocked state. Fine. So now task one is done. It is succeeded. And if you look at task two, it is in running state. All this we are doing manually, right? Run now, manual trigger it is, but we have provisions for scheduling, right? You can say that this entire thing should get executed at so and so time through the schedule option. Fine. So task two is happening, which is the execution of the pipeline. But as I believe previously, right, I had tweaked the script of the pipeline. So I think it's going to fail. Let us take a look to show you that if the things are breaking, how to navigate and fix them. I had changed the path exactly, right? Yes, the volume path, right? I had given it wrong, so I am fixing that. Meanwhile, let us see how it is going to comply. Fine. So it says here it is broken, correct? So it's broken. It says failed, and let us try to see the results of that. I will click on this run, and here it says that task 2 is failed. Task 1, if I look at, it says it is done, right? You could see tick mark, the notebook is executed. If this result you want, you can export as HTML and all. But our interest is not task 1. Let's go to run details again. Let's click on task 2, and here you see the detail. It says it doesn't exist, right? Verify that the volumes are actually existing, right? That error we have. Anyway, I fixed it. So now we can retry, right? Executing the job. But this time you may get questions like, should I be executing the entire flow once again? Need not. Our task one is successfully done. So now we should be executing task two only. That's where we have option of repair run, right? It will ask which one would you like to repair. So this is the one I would like to repair, right? So let us say uh, repair run, right? And is that happening? One second. It took us to the pipeline. One second. Repair run we did. Let us select this. Okay, select already selected. These two are already selected. I believe these parameters we don't have. Okay, they're already selected because they are failed. So let us say repair run. It is listing here the number of tasks that are selected. So repair run, let us say. So these two will get uh, repaired. So it is showing for this the two attempts. Okay. Task three last time, right? I attempted by deselecting this. That's why it is a third attempt for task three this time. And it is taking a bit of a time. Done. It's done. And now task three should get executed. Yes, it started. Task two, if I check through the results, right, it says it's a pipeline, right? And here itself, the entire pipeline is embedded for us, and we can take a look. Let me go back to the run. Task 3 still happening, which is about displaying the contents of the materialized view. If you want, so depending on the tasks that we put across, right, this place gets occupied. I don't see provisions of, moving across this thing like in ADF. Taking quite longer than expected. Let's see what's happening here. It's still working upon that, right? It is our script. Yes, we finally got it. Fine. So this way you got a quick idea upon what are Databricks workflows and how can you create a simple workflow and how can you trigger it manually and troubleshoot if at all some errors are happening. Okay, that's all for this video. Thanks for watching. Stay tuned. Hi everyone. Welcome to my channel Data Tales. In this video, I will be discussing about Databricks alerts. This is 11th video in Databricks 101 series. If you have not watched previous videos, please do check them out. Let's get started. Alerts are about notifying someone when something goes wrong. How can we set up the alerts in Databricks? Imagine a sales related use case. You may have to notify the sales manager whenever the daily sales are going below expected target. It could be something around $5,000, let us say. Let us see how the alerts are going to work in Databricks based on SQL query. Just a second. Let us consider this example. We will be sending notification based on certain condition. The condition can be in the form of querying the result from the table. When the query fetches certain column data greater than a defined threshold, we can send alert to concerned stakeholder. Likewise, with respect to our data pipelines and workflows, if something breaks, we can notify the concerned person. Let us take here a very simple example. We will be trying to set alert against the very simple query like select some constant value, and this is the alias for that value at the column. We would like to notify whenever this select query gives the count value to be greater than 100, or it could be 10, let us say. Now, when you create the alert, by default, immediately after creation of the alert, the state of the alert will be unknown state. That is one thing. But how often you go about alerting the required stakeholder? For that, it depends on how often you are executing the query or how often you want the alert to be sent to the stakeholder. That's why associated with the alert is the schedule. You may want the alert and the associated query to get executed every minute or every day. For our sales case, we can say we want the query that fetches the total sales to be executed every day. And if that query is fetching the total sales to be less than $5,000, we want to notify the sales manager. So that way, depending on the scenario, we can go about scheduling it. In our case, to see that properly and understand the alert mechanism, I am going to schedule the alert and its associated query to get executed every minute. Let us say at 10 o'clock, I am creating the alert, which is against the query select one as count. So immediately after the alert creation, status is unknown. But since we have scheduled the query to get executed every minute, at 10 o'clock 1 minute, the query gets executed. Since here we will be just trying out to understand, manually we will be changing the numbers that are fetched from the query. I'm just altering it to fetch 10, okay, before 10 o'clock 1 minute. So with that state, if this query goes for execution after 1 minute, it will be in the OK state because 10 greater than 10 is not the condition that we have specified for the alert. Okay, so it will be in the OK state. Let us say before our next execution, I am changing my query to select 20 as count. And when the query gets executed at 10 o'clock 2 minutes, it will move from OK to triggered state, and you can send mail to the stakeholder. Likewise, let us say before the next execution, if I change the value to 25, query gets executed at 10 o'clock 3 minutes. Again, alert will be in the triggered state itself because 25 is greater than 10, but we may not send the mail because already mail is sent with the uh, triggered state. This is just the notification type. If you want, you can again send the mail. Most likely, we don't prefer it. There are again options available how often we would like to get the notifications. Let us say again, before the next very execution, I'm changing the value to 10. So when the next execution happens, the state of the alert gets back to OK. Likewise, followed by that, if select 5 is done, state is still OK. But after that, if it is fetching 25, then again, alert is moving from OK to triggered state. So this time, we will be sending the mail again. So this is one of the pattern that we can use with respect to the alerts. It could be that you can choose to send alert for every execution and whenever the status is triggered. Okay, that kind of options also we have. Let us check through them. Let me go to my Express edition. I will be writing my simple query that I spoke about. Let me say select one as count. Fine. This is a query we are writing in the SQL editor. I don't have the serverless this warehouse up and running. So let us maybe go to the menu and start it quickly and come back here. Okay, let us start it. Well and good. Let's go back to our previous uh, workspace options. That is a SQL editor. Let's give a name to this query. Let me call it as my query, and we should be saving it. Fine. Where you would like to save this? In the default location, let us say workspace users and the username. Let us save it. So with that, this query is saved here. You can check through from the queries menu as well. Fine. So this is a prerequisite before you go about creating the alert, because here we are trying to create alert based on the query result. Now let us go to alerts, and here I have provision of create alert. You can give name to it. Let us say it as my alert. It will ask based on what query you are creating the alert. I say it is my query. Uh, it is yet to show up here. Let us check through it. Yes, it is available now. And after selection of the query, it is asking to set the condition. Based on what condition of the query you would like to trigger the alert. Fine. We will say the column will be count for us. That is the only column we have. And we are picking the literal value. So it is a first row. Always this is going to just written as one row only. So first row, but then we have multiple other options. Okay, you can go about setting the alert whenever maybe some of the column, count of the column, something like that is breaching the threshold. Here I'm checking whenever the count of the whenever the count value is greater than threshold value. Threshold I will set it to be 10 maybe, right? We would like the alert to be executed or notified or triggered, we could say. Fine. When query result has no rows, set the state to unknown. This is the default. That's what I was mentioning. So when we create the alert, by default, it will be in the unknown state, but you have provision of choosing. Okay, at the beginning, in what state you want your trigger to be, let it be unknown. We have not yet executed it. At this time, you have provisions of previewing the alert and all. We can check through. Let us click on this preview. See, it is telling alert would not trigger with the current data. If I set the count to be 2, threshold is 10. That's why alert is not triggered and its state will be okay. See, like that, it is giving the preview for us. Next up here, when the alert is triggered, would you like to send the notifications? Yes, when alert is triggered, send notification just once until back to normal. So this kind of state. Okay, you will be just sending the alert once until back to normal. It is okay. It wasn't triggered and again it triggered, and this is a normal until it is normal again, right? You need not send the mail. Okay, you will send the mail only when it is traversing from okay to triggered state. So that's a kind of configuration we are doing here. And when actually the alert is returning back to normal, right? For example, this happened here. It was in triggered and next it is returning to the normal. Normal is the okay state here. At this time also, if you want the alert or the notification to be set, you can configure it here. Send notification when alert returns back to normal. If you want to send the notification, that provision also we have. As of now, whatever default is there, it is this behavior. It will send mail for the first time, okay, when the alert is triggered. If at all that alert is in triggered state only for the subsequent executions, you won't get mail. And eventually it may go back to okay also, then also you are not sending mail. But when it is transitioning from okay to triggered, you are sending the mail. So that is the default setting that we have it here. And in what manner you would like to send notification? We have default template, but otherwise you can go about providing the custom template as well. You can choose how your body or subject should be for the mail and all, and you can get to preview it. But then let me stick on to the default template. Well and good. With these details, right, we can create the alert now. Did we name our alert? Yes, my alert is the name of the alert here. Let us say create alert now. Create alert. Well and good. Alert is created. You get to see them listed over here from the menu. Let me just scroll up 1 second. Some issue with the cursor. Fine. Last triggered at none. Query is my query. So this is a triggering condition that we have mentioned. All that information we have it. Here we get now the provision of adding the schedule. Let's go for add schedule. And here we get to choose how frequently we want the alert to be triggered. I say here every 1 minute. Let us trigger it. Fine. And it's asking for a destination. I will go about here and I will search for, or I will mention the mail, my personal mail I'm mentioning, and we could say create. So the alert and the query behind it will be executed every 1 minute automatically. Now this should happen automatically since it is every 1 minute schedule that we have given. Even we don't run it. Even though we don't run it, this should happen automatically now. Let us see if it happens or not. And here we should remember that as of now, our query is fetching the value of 1. This is our query, right? It is fetching value of 1. So obviously it is in okay state. I should not be receiving any mail. Let us refresh it. Is it 1 minute since the time we created? No runs it says so far. There can be minor delay. It's not in pause state. It is supposed to be in executed automatic state only. I'm just trying to refresh. You could see after refreshing the page, it is showing up. And at the beginning, you noticed it or not? It was in unknown state, right? Now it has moved to OK state. Let us do one thing. Let us go to query and let us update it to uh, maybe 20. Let us save it. After updating, don't forget to save it. Let us save it. And again, let's go back to here and let us try to refresh. Meanwhile, I will keep my Gmail open also. One second. We have it here. It should, right? It should trigger and we should be receiving the notification here. It has moved to triggered state and I should be receiving the mail if the mail address is correct. There can be occasional delays. Let us check through. Maybe eventually we will be getting it. Let us try one more value. Let me move this back to 5 or something like that. Let us save it. We will observe whether alert is going to transition back to normal. OK state. Maybe a small problem. I'm not receiving the notification. This also let us refresh. Yeah, it has moved to OK state now. This is what we should be understanding. Fundamental alert related concept. I should have received the mail, but seems like small glitch is there. So I'm not getting it. Mail address is correct only. And if I look through the settings, right, everything is fine. Notify destinations when alert is triggered. It should have, right, sent mail to us. I have observed that sometimes the mails are coming a bit late. Fine. You can check through. You should be receiving mail. Previously, I have checked it and we work with it, right? We do get alerts. Fine. So this is all for this video. Next up, I will be discussing about Databricks live tables and workflows. Thanks for watching. Stay tuned. Hi everyone, welcome to my channel Data Test. In this video, I will be discussing about Databricks constraints. This is the 12th video in our Databricks 101 series. If you have not looked our previous videos, please do watch them out. Let's get started. We use constraints in RDBMS to ensure the data integrity. And it is very common to use check constraint, not null constraint, primary constraint, and foreign key constraint. Do we have such kind of constraints in Databricks? Let us check them. We will try to understand these constraints with the help of the example. First, we will look at how they are working in the SQL world. Later, we will go about implementing the same in the Databricks and we will try to compare. One second. I'm here at the Microsoft Management Studio. I will be connecting to the Microsoft SQL Server from here. I have the database by the name DB already created. Let us try to create simple tables here. I will be taking example of the student and department. Let us first create the department table because I will be trying to use the students who will be studying in different departments. So let us first create the departments table. Let me first ensure that I will be using the DB database. So use DBISA and let me execute it. Let's again now go about creating the table. Create table department, a department ID integer. We want it to be primary key. Then dname is a department name, which is going to be of string type. So let us just execute it. One second, let me check. It says we have the table by that name already. I had dropped it. Anyway, let me just say it as department one. It is still not reflecting. That's why maybe it is successfully created. Now let us try to insert records into it. I will go about inserting very small and simple record here. Insert into department values. 10 is our department ID and department name is data science. Let me just execute this one. It says, excuse, my bad. It is department one. Let us execute it now. It says one row is affected. So successfully we have inserted the document into the department one table. If I try to re-execute it, primary key by default, it expects the department ID to be not null and unique. If I try re-executing it, the department ID is duplicate here and it should be giving us error expected because we are violating the primary key constraint here. Fine. So this is a default behavior from our RDBMS. Next, let me create one more table. It's going to be student table and it will be referring to the department ID of the department table. So foreign key relationship, we have it here. So create table student one, let me say, and it's going to have student ID, the primary key, the student name, which is going to be not null. So I'm trying to bring here the not null constraint. Then I have this as department ID. So this department ID from the student table will be referring to the department table department ID. So this is how we go about defining that constraint. Foreign key. Foreign key here is SDID. References department DID. Great. Let us go about executing it. It should be working fine. Well and good. Let us insert a record into the student table. What shall we do? Just in the interest of time, I am copy pasting the commands. But when you happen to practice them, please do type and practice. Insert into student. Student 1, I will say. Values. So and so. This should be working fine because in the department table already the value 10 is present. Let us execute it. Well and good. It happened. Let me try to execute one more insert. This time, let me try to refer to 20. 20 is the department ID. But this department ID is not existing in our department table. So will this work? It should not. It is saying that we are violating the, first of all, it is violating the primary key itself because 1 is there. Maybe let us fix it. Next thing is, let us check now whether it will execute. Uh, it's taking it because by mistake, I am referring to the old table. This is supposed to be the new table. Fine then. So what I do, I will create a new table. So these I will update, right? So that way, I think we can check through. Fine. Let us execute it. New table I have created and let us insert one record into it. Fine. And here I'm trying to violate the foreign key relationship and it is complaining. It says conflicted with the foreign key, right? So this is a default behavior. And now let us try to check upon the not null constraint thing. Maybe let me just duplicate this statement and let us make student ID to be 3, but name, let us try to make it as null. Will this work? It should not. Right? It says we can't do it because a column does not allow nulls. Fine. So this is how the different constraints are working here. Let us try to bring in here the check constraint also. Let us say we want our student IDs to be greater than 0. That should make sense, right? So I go about, I didn't define it while I declared my table and all, right. In the table definition, we didn't do it. So we go about altering the table, alter table student to add constraint. This is a constraint name, check SID to be greater than 0, we will say. Fine. So this is working fine. And now if you try to insert a record wherein student ID is going to be less than 0, uh, we should get error, is it not? Fine, let us check it. I'm trying to insert -1 as the student ID. It says invalid anyway, that is also there. And student 2 it is, execute, it says there is conflict with the check constraint. So this is how different constraints are working. Similar kind of constraints, primary key, foreign key, check, not null, are supported by the Databricks, but how they are going to behave in the Databricks world, let us see it. I'm going to my Databricks Express Edition account. Let me go to compute, and here let me start my SQL warehouse first. Then we can navigate to SQL editor. So whatever we did there, we can try to replicate here. Let me first create database also, and then we will be trying to creating the table and all. 1 second. Let us check through it. Let us execute all of them, and with that we should be getting the, it is still working upon it. Here if I extend, I have the DB database created. Let us create the department table first, and we will be trying to insert the records into it, and we will observe whether foreign key is going to work similar to how it was working in the SQL world. Fine. So create table, department, department name, department ID is the primary key. Let me first create the department table. So I have selected only this part. Let me execute it. Well and good. It got created. You can observe from here. Let us check through. No data, it says. Use DB we did, but it is going into default. Okay, I think, yes, it is going into default. Let us switch it. Let us switch to DB, and now let us execute it. It should be creating this table in DB database now. Fine, we got it. It's in the DB database. Well and good. Let us try to insert the record. Insert into department values. Department ID 10, department name to be data science. It is working fine. Let us retry. Retry executing. So duplicate primary key, right? Will this happen? It will happen, right? No error. So it got successfully inserted. So you could see here, though we can define primary keys in Databricks, they are not enforced by default from the Databricks end. We can still use it so that we will be having good idea about what kind of data we are dealing with. It is the data engineer's responsibility to assure that the column is having unique and not null values. Fine. Let us now check through the foreign key constraint behavior. It is similar to primary key. The foreign key is not enforced. Let us go about creating the student table first. I'm here. Create table student. student name, and so foreign key, same thing as in the previous execution. Okay, it is created and no record so far. So DB has department and student. Let us insert the record now. We will check foreign key. We already checked. It's not enforced. We will check whether excuse, primary key. We checked that it's not enforced. Now we will check for the foreign key. 1 second. Insert into students values 10. This should be working fine because 10 already there. Fine. Let us see through. It is there, right? It got executed, no error. But if I try to again, right, try to insert the student record, which is going to refer to the department 20, which is not there. I didn't execute this particular statement so far. You can quickly verify, maybe select star from department, let us say, and let us just execute it. We can check just we have, the department ID 10. I'm trying to create a student record that is referring to the department 20. In our SQL world, it was failing. Here, what will happen? This will still execute. So foreign key is also not enforced by Databricks. Fine. Let us check if the not null constraint is enforced. Let me copy the same statement and let us give here, uh, anyway, that should have worked. Let me try to give here null. Fine. Let us try to insert and check. Student name should not be null. That is the constraint we have it in place. Is it enforced in Databricks? Yes, it is enforced. Not null is enforced constraint in Databricks. It is giving error to us. Likewise, let us try to bring upon the check constraint here. We will alter the table and we will add upon the check constraint. And this is the way you should be. Hi everyone, welcome to my channel Data Test. In this video, I will be discussing about Databricks constraints. This is the 12th video in Databricks 101 series. If you have not watched our previous videos, please do check them out. Let's get started. In the SQL world, we define constraints on tables to ensure data integrity. Is it possible in Databricks as well? Let us check it out. 1 second. First, we will observe how constraints work in SQL world. I'm using here Microsoft SQL Server and SQL Server Management Studio, which I have installed in my local system. First, let us get started with creating a simple database. 1 second. In the interest of time, let us resort to maybe utilizing the existing statements. But when you practice, ensure that you are typing and practicing this. Fine. I'm creating database by the name DB2 and I'm switching on to using it. Let us say execute. 1 second. Let us try it. Let us now say use DB2. It's well and good. Next, let's go for creating a table. I will be considering student department example. I will be creating department table with just 2 columns, department ID, department name. Department ID, we want to treat it as primary key. Let us create department table. Well and good, it's done. Let us try to insert record into the department table. Insert into department. The department ID 10, department name is data science. Working fine, no error. If I re-execute it, what will happen? It throws error because we are violating the primary key. Primary key by default is not null and unique. Already 10 value is there for the department ID. We are trying to insert again, so it is a duplicate. So we are violating the primary key, and that's how primary constraint works in Databricks, in SQL. Let us now try to create one more table. We will take that to be student table. In the student table, along with the primary key, we will try to have foreign key as well. Student ID is the primary key. Student name should be not null. So here we are using the not null constraint. And department ID will be referring to the department table because each student will be belonging to a department. So that's where we are defining here foreign key. The student department ID is going to be foreign key referring to the department ID of the department table, right? Such way we are creating the table here, student table. Well and good. Let us try to insert the records into it. 3 columns we have. We will try to insert the student ID, student name, and the department. Student ID 1, name is Ram, and department 10. Department 10 already there in our department table. So we didn't see an error. This is working good. Let us try to insert one more record. Let us say student ID to be 2. Name, let us try to make it as null and check what will happen. We have defined not null constraint on the name column. So we are violating it. So we get the error. Let us try to now uh, insert the record with the name maybe. 2 is a student ID. Ram is the name, or let us change it to something like this. And let us make department ID to be 20. Will this work? No, because we are violating the foreign key. We are trying to refer to the department which is not existing in our department table. So far, the only department we have is department with the ID 10, right? So we are violating the constraint. To overcome it, first we should be inserting a record into department table with the department ID being 20. Let us do it. Afterwards, if you come to this statement and if you execute it, this works fine, right? So this is a behavior of primary key, foreign key, and not null constraint in SQL. Let us try to bring up on here the check constraint as well. We want our student IDs to be greater than 0. So for that, what we could do is I will alter my student table and I will make it we want the student ID to be greater than 0. So such a way we are defining the constraint. Alter table, table name, add constraint, constraint name, and the check clause. Fine. Let us execute it. It is successfully executed. Now let us try to insert record into the student where student ID will be less than 0. -1 I am giving. Will this work? Obviously no, because we are violating the check constraint. So this is how we can take a quick refresh on to how the constraints are working in the SQL world. Let us try to replicate it now onto the Databricks platform and check, are they going to work exactly same or in a different way? What shall we do? We will create the database first as we did in the SQL. Create database DB2, use DB2. I'm executing them. With that, database should be created for us and it should come up over here under this workspace catalog. Serverless, okay, it is still working. It was paused maybe. It got created. We have the DB2 here now. Well and good. Let us create the department table and let us insert one record into it. Let's go here. Create table, department. Primary key is still the same. Exact same syntax, no changes. Fine. All of this, let me try to execute. We have a problem. Here we should change it to DB2. Fine. Let us try it now. This works. No error. Let us try to insert the record again. So we are trying to duplicate the department ID, but there is primary key constraint on the department ID. Will this work? Yes, it's working. But in SQL, it was complaining. So what's the takeaway? In Databricks, the primary keys are not enforced, right? Let us now try to create the student table, and it will be having foreign key reference onto the um, department table. Okay, as we did earlier. Fine. So all these changes we have. Fine. This is our table just like earlier. Let us create the student table. Same exact things. Let us try to replicate and check whether it's going to work. We will try to insert the record of a student who belongs to department ID 10. This should be working because department anyway it's there already. It should not complain. Well and good, it's working. But what if I repeat it? I repeat, but I'm changing the department ID to be 20, which is not existing in the department table. If I execute it, is this enforced? No, right? It is still working, so it's not enforced. So primary key, foreign key are not enforced in Databricks. Fine. Is the not null enforced? Let us check it. Let us try to pass this to be null. It says not null, constraint is violated. So not null is enforced in Databricks. Fine. We have the last one, that is a check constraint. Let us try to add check constraint onto this student table through the alter statement. We want student ID to be greater than 0. Well and good. Afterwards, we will try to insert a record with the ID being less than 0, and we'll observe whether this constraint is supported in Databricks or not. Yes, it is supported. It is violating the constraint with values and all it says. So with that, you can infer here. We have two kinds of constraints in Databricks. One is the enforced constraints, and second one is the informational constraints. This foreign key and primary key are the informational constraints in Databricks. We keep it so that it is good for us to track through the importance of the keys in the table. So as a developer, we have to take care of enforcing the primary keys and foreign keys through our logic. You can observe here. Uh, Let us check through. Let's go to catalog. We should be able to see these keys being defined. Let's go to catalog. Let us expand upon the database and the table. So we have student table. You could see it says that student ID is the primary key. So looking at this one, so we should be able to make out that we are supposed to treat this to be primary key and this one to be foreign key. Likewise for department, just foreign key will be foreign key is not there, primary key will be highlighted. Even we get to see, one second, let us check through the relationship between the tables. Here the student table has primary and the foreign key, right? So here we have option of view relationships. So this way it will be easy for us to track through how the tables are depending on each other. The relationship diagram, the ER diagram, which we design in our SQL and all, right? So with that, in this video, I hope you learned the very important concept, that is enforced and non-enforced constraints in Databricks. Thanks for watching. Stay tuned. Hi everyone, welcome to my channel Data Test. In this video, I will be discussing about Databricks dashboards. This is 13th video in our Databricks 101 series. If you have not watched our previous videos, please do check them out. What are Databricks dashboards? In general, dashboards are the visual representation. By looking at the dashboard, we will be able to understand very important metrics related to our business. In this video, I will be showing you how you can turn your Databricks SQL query result into very impressive, meaningful, insightful visual representation, that is the dashboard. Let us get started on it. I'm in my Databricks Express Edition workspace. Here first, let me go to Compute. Let me turn on the SQL warehouse, which is the serverless warehouse here. Now let me go to SQL editor. Here, for the demonstration purpose, I will be making use of the samples provided by the Databricks. Under the samples catalog, if I expand upon, we should be seeing that there are 4 to 5 data sets provided to us in the form of databases. In that, we have TPCH. Here we have some sales related tables. Let me expand upon it. You can take a look. 1 second. Customer table is there, line item table is there, nation table is there, orders, part, region, supplier. Like that, we have few tables. Let us try to query these tables and get some insights. Let us start with very small one. There is orders table here. Let us try to query against this orders table to find the number of orders by their status. There is order status column here. With respect to that, we can select here, select the order status, group by the order status. That way we get the count of orders against each order status. Let this be one query. Let us try to execute it. Before we execute, we have to choose here the catalog and then choose the database. Let us run this query. Whatever we get here, this is a raw result, excuse. So we have the order status and their count. Now, this result you can turn into visualization. You have to click on this plus. There is visualization option. You get to choose the kind of the visualization you want. Let me choose here the pie chart. We are good to go. It gives us the failed orders, maybe pending, something like that. We have the order status. Let us save this visualization. We can give a name to it. Let me call it as order status distribution. Fine. So this visualization we have created. Next up, let us try to find average order value. Again, something we can derive from the orders table itself. Year-wise, we will try to find here the average order value. You take look into these details. Later, I will be posting all these queries in my GitHub. You can just refer to and practice on yourself. Let us first execute this query again. It should be switching to the samples. and then to the, excuse, this is samples, and then your TPCH. Done. Let us execute it. Year wise order value we are trying to find here. Done. Let us visualize it. Let us go for maybe line chart. Horizontal chart is fine. On the x-axis we have the year, and on the y-axis the order, average order value is there. There are ups and downs here. We can observe it. Let me save it. So this way you are nicely observing that our query result can be visualized, right? Let us save it by the name average order value. Right, done. Next up, let us try to find revenue over time. Again, against the orders table, let us switch to the samples and this TPCH here. Let us execute it. Done. Let's go for visualizing this result. This was uh, okay. Revenue over time, right? Let this be like this. The line chart. Over the years, we could see that there are ups and downs, and it is being restricted to certain boundary. Let us save it. Let us call this as order value over time, or revenue over time. It is, excuse, revenue over time. So this is what we have it. Done. Three queries and visualizations we created for its result. Let me check if I can have one more here. Let us try to find the top selling nations. Okay, top selling nations, the samples, and then we have TPCH. Let us execute it. Place visualization. Horizontal chart is there. Let us make it as a vertical chart. So revenue on the y-axis and countries on the x-axis. So these are the top 10 selling nations we have. Fine. Individual visualizations we have created. Let us name this as well, the visualization. Let me call it as top selling nations. Done. Now, how can I create the dashboard? We can create the dashboard starting from here itself. Click on this down arrow. There is provision of add to dashboard. Let us select it. Let us create a new dashboard. Let me call it as sales, and let us say save query and create. Likewise, the other visualizations can be added to the dashboard. Uh, Down arrow, add to dashboard. Let us say this time add to existing dashboard. Here, our newly created sales dashboard, we can pick it. And let us say save query and import. Fine. Let us add the order status one as well. Quickly to dashboard, sales, save query and import. Save. Done. Last one we have revenue over time. Let us select it. Click on this add to dashboard, add to existing, say sales, save query and import. So with that, what happened? The dashboard is created for us and it is already opened for us. But then if you want to navigate from the main menu, you can do so. Let's go to dashboards. You could see certain, dashboards are already there. The samples given by Databricks. But then we created here the sales, right? Let me click upon this. By default, the layout comes out to be one below the other. Top selling first, average order value, order status distribution. like that. And revenue also is there at the end. We can organize them by dragging and dropping. Let me bring upon this average order value over here. Likewise, let us just adjust this little bit, and let us scroll down here, further scrolling down, and let us adjust the placement of these visuals here. One second. Let me zoom in little and let me place across. Um, okay, we can just adjust the size and all. That should be fine. We are good here. Let me stop it. But then we lost this somewhere. Uh, okay, this one we are supposed to push to the top. Let us take it here and let us adjust the size as well to fit into the first one that is there. Yes, done. Okay, this one, something is pending here, right? I'm just trying to put it in the quadrant. So this one we will put it up here. Okay, fine. So with that, now our dashboard is ready. Let me zoom in little so that you can take look at it. Okay, still further, there isn't much room here. One second, let us check through it. Further, you can okay, edit this. You can add further visuals, or you can go about filtering. Okay, this is just one page that you have created in your dashboard. You can give a name to it. Just like in Excel, we can go about having more sheets, right? So we can have here the um, more pages, dashboard pages. Let me say this to be basic page. Fine. So like this, you could see that we are able to create the dashboards. Let me further maybe just downsize them so that we can see them together. Okay, this size also, let me reduce it. Let me try to bring this up. One second, let us check through. You can place them wherever we want, right? I think now you got the bit of better picture for this dashboard. Fine. So this is the one we have it. Fine. So like this, you can try to build upon your dashboards depending on your business use case. You may be getting instructions or problem statements from the lead or your clients, and accordingly you can do it. So we have here the option of publishing. So where you want to publish and to whom you want to notify whenever this dashboard is published. So that kind of information also uh, we can provide. Okay, you can give the link to this dashboard so that others can see it, and you can share this dashboard with your required stakeholders, and you can set the refresh frequency and all. This is a dashboard that is refreshed 10 minutes back. Fine. So like this, you are seeing here that we have the visualization feature baked into the Databricks platform. So you can build your dashboards within the platform without maybe relying upon the additional tools like Power BI and all. But then, if at all you are more convenient with Power BI, and your requirement is that you are supposed to build your dashboards using Power BI also, Databricks uh, supports that integration very nicely. We get to see it somewhere here itself. Let us check. We should have provision here of connecting to the Power BI, maybe this is the Express edition, right? So we don't get to see it. Fine. Okay. So depending on how frequently your queries are refreshed, you can enable your dashboard refreshment as well, so that your dashboards are always staying updated. Okay, so this was the concept of creating dashboards from your query result in Databricks. Uh, I think with this, we have almost completed the promise set of the topics for the Databricks 101 series. Uh, Let us meet with maybe new set of videos wherein we will try to dive deep into the concepts that we have taken up here in this series. Thank you. Stay tuned.